When dealing with complex tasks with distant objectives and large state action spaces, reinforcement learning algorithms often fails to quickly produce a successful trajectory to learn from. Meanwhile, large language models have shown their reasoning capability of task planning. So by the idea of task simplification, in this work we leverage LLMs to guide our L agent for goal-based exploration and training speed-up. Although pre-trained LLMs are good at high-level task planning, they can bring risks when it comes to low-level action decision, especially when directly planning towards distant task objectives. For example, to put an object into a closed microwave, or interact with the TV when both hands of the agent are occupied. These are potential constraints in the environment that can be easily ignored, leading to unavailable actions in the current state. To address the issue, we propose to simplify complex long-horizon tasks by dividing them into multiple sub-goals. Given the brief task description, an LLM module goal generator tries to produce a sequence of desired states in text along the task completion. We also insert the caption of the initial state into the prompt. Thus, several goal states can be imagined to model the task world and guide the agent to achieve them one after another. After that, given an state in a rollout, it is first translated into language text. Then combined with the current goal, another LLM module policy generator outputs an action sequence to reach the goal. For online replanning, we choose the first action from the sequence and repeat for the next state. And we calculate the difference between the agent and LLM policies as additional loss for the RL algorithm for optimization. And during the rollout, a goal inspector measures the cosine similarity between the encoded embeddings of the goal and the state caption to check if the goal is reached. We test the proposed framework in different environments with complex long-horizon tasks. The first two tasks depict the scene where the agent figure needs to perform daily activities in a virtual home environment. The second is a robot manipulation scenario. Roman depicts a scene in a laboratory, where the robot arm needs to manipulate and transfer objects using a set of available action primitives, and the continuous state space adds to the complexity. We test our method in two versions of this environment, with a short and long time step sequence, respectively. After training, the learning curves and evaluation on task success rate in the task environment with noises demonstrates that our method learns quickly during the initial phase and maintains stable progress during training. Besides, our method achieves better results with environment limits considered than solely using LLMs for planning. In addition, our approach is robust to hyperparameter settings, and performs well even with uncertainties in environment observations. Thanks for your watching.